Dear grade 9 students, in today's lesson we're going to complete what we started about the acids and bases. To remember, we started about acids and bases and we explained what do we mean by acid, what do we mean by base, and we also studied about the pH and the indicators and how to determine whether it's acid or base or weak acid and weak base by examples of indicators like the pH scale or the universal indicator, and also methyl, orange, or phenolphthalein, and the most famous and primitive one, which is litmus paper, the red and blue. In this video, we're going to discuss the reactions. First, the reactions. First, the acids with metals. Acids react with metals such as potassium, sodium, calcium, magnesium, aluminium, zinc, iron, and tin, right? To produce hydrogen, gas, and salt. So this is a general formula. Acid plus metal, I'll write it here, acid plus metal gives hydrogen gas. This arrow up means that there is a gas evolving plus salt. Here are two example equations, right? Molecular equations. Molecular equations means, okay, here's potassium with HCl gives salt, which is potassium chloride and hydrogen. Of course, to have a correct equation, you have to balance it, okay? Another example, zinc. Okay, zinc plus HCl gives zinc chloride and hydrogen, also it's balanced. So the first type of reaction for acids is the acid with metal produces hydrogen gas and a salt. The second type of reaction is acids with carbonates. Okay. The acids react with carbonates. Carbonates, do you remember the carbonates? Carbonates CO3, and that's -2. So when acid react with carbonate, and hydrogen carbonate, which is HCO3 or bicarbonate. Here's one example. They produce carbon dioxide, salt, and water. So also this is a main formula. Acid plus carbonate or hydrogen carbonate gives CO2, H2O, and salt. See, that's easy. Okay, let's take two examples. Hydrochloric acid with calcium carbonate. What are the products? Simple. CO2 without looking. H2O there, and there is your salt, calcium chloride. Also, it's balanced. Okay, now with hydrogen carbonate. Here you have HCl with sodium bicarbonate. This is the baking soda, or sodium hydrogen carbonate. Gives again CO2, H2O, and there is your salt. So now you have two types of reactions for acids. Reaction with the reaction with metal. Reaction acid plus metal gives hydrogen gas plus salt. Acid with carbonates or hydrogen carbonates, or it has another name, bicarbonates. It gives carbon dioxide, water, and salt. This is something for you to check. Write the products of the following reaction. You have zinc plus hydrochloric acid, and you have magnesium carbonate plus hydrochloric acid. This is for you, an exercise for you to do. Another type of reaction between acids and bases is neutralization reaction or neutralization equation. What is neutralization? To start with that, neutralization is the reaction between acid and base, and that reaction gives salt and water. So in the equation of neutralization, an acid and base produce salt and water. And here are some examples. When you react hydrochloric acid plus sodium hydroxide gives common salt, sodium chloride plus H2O. Another example, when you react hydrochloric acid with calcium hydroxide, it gives calcium chloride, which is also a salt, a calcium salt, plus H2O. Okay, basic compounds in some antacids. What's antacids? Okay, let me give you a simple example. Sometimes when you're eating a spicy food, you can feel that there's some burning sensation in your chest. Okay, this is called a heartburn. Okay, when you go to the doctor, how can you beat that, or how can you treat that heartburn? You can treat it by drinking something, an example called milk of magnesia. Milk of magnesia is actually magnesium hydroxide. Magnesium hydroxide is base. First, let me explain how this heartburn happens. So when you're eating more spicy food or a spicy food, and you know that there is in your stomach there is strong acid, which is hydrochloric acid, remember? So when you're eating that spicy food, you're increasing the exertion of the HCl, or the exertion of the stomach acid. So when you increase that, you feel that burning sensation, or you feel the heartburn. So to treat that, it's an acid. So to decrease the effect of that acid, you need a base. So an example of that base, there are many medicines. One of them is milk of magnesia, and there are also tablets. These tablets, like these ones, are used to decrease the stomach acid. And by decreasing that, or by drinking that, or taking these tablets, these are some examples of these tablets or these medicines, like the milk of magnesia, which they are all react as bases. So when you drink that, or when you use that, you neutralize the effect of your stomach acid, and that's how you can treat the heartburn. Another examples you can use, there are many examples. For example, the bee sting. Yes, the bee sting, it stings, right? And it feels also like a burning sensation. Do you know why? Because the bee sting actually is acidic. So to treat the bee sting, there is a small and quick remedy. You need a base. If you have an acid, to neutralize the effect of that acid, you need a base. And the simple base you can use, for example, you can use soap, because soap contain base. And another simple thing, you can use the baking soda. Yes, the one you use in cake. So the bee sting is also acidic, and to neutralize it, you can use soap or baking soda. Another thing, the wasp. Okay, a wasp is also an insect, and it has actually, the sting of it is basic. Yes, and it also burns. So to treat that, you have a base burn. So to treat that, you can use lemon juice, you can use vinegar. Okay, these are some of the uses of neutralization reactions in our life. So as far we know now, three of them. First, treat the heartburn or the stomach acid by using antacids, and all of them are bases. As an example, milk of magnesia, to neutralize the effect of acid in our stomach. Another example, to treat the bee sting, which is acidic, we can use soap or baking soda, which works as base to neutralize the effect of the sting. A wasp sting is basic, and to neutralize that, we can use weak acid like lemon or vinegar. Now to the acid base. Acid and base, we said that they are called neutralization reaction, and they produce both water and salt. The acid-base reaction happens by titration. In titration, we use two things. This is called, this device, this is called burette. Yes. And this is, of course, a conical flask. And you can use pipette. Pipette looks like a long tube and it's graded, okay, which you can just pull the amount of the substance, which is acid or base. In titration, this is the procedure or the how to neutralize the acid and base. So you can put the base in the burette, and it's also, can you see there are grades? This is the volume. From here you can determine the volume of acid or base, and actually you can put acid or base both. It's the same. So in this reaction, when you add the base and in the conical flask, there you have the acid. First, when you're using the acid, here you have to add also the indicator. So the acid in the conical flask, or the base for that matter, and the indicator. Okay, when you add the indicator to the acid in the flask, it will take the color. Remember the colors, we studied that, the colors of indicators, how do they change when they react with acid and base. And you start dropping the base, just drop by drop. And after each drop, you have to shake the conical flask to make sure that it's completely mixed. Okay, so for example, here you have an acid and here's a drop of indicator, and you can see that it's turning pink or red, right? So when you add a drop, you will feel that the color is almost gone. When you the color is changing, but when you just shake it, the color will again becomes red. So you keep doing that. After each drop, you have to shake carefully just to guarantee that it's all mixed, and then until the color change into where it's supposed to be neutral. And that is called the equilibrium or the end point. The end point is the point that the solution is nor acid or base, it's neutralized. That's why it's called the end point or the equivalent point. The end point of titration. At the end point, the indicator gives the solution a permanent pink color. So the color does not change. And be careful, at that point when the color changes, do not add any more drops of base, because this will turn it into a basic solution. So the volume of the base used to react at the end point is measured, and you can also measure the molarity of the acid. Molarity means the concentration can also be calculated using the neutralization equation. This was our lesson for today, and hope you can see the questions within the video and solve it as homework. Thank you, stay safe, and hope to see you soon.